Euclidean Geometry Exam Questions Grade 12, November 2020, Paper 2, Question 8 from DBE. Okay, Question 8 from DBE, November 2020. Okay, so solution 8.1. We are going to answer 8.1.1, question A. Okay, so you can read the question. Okay, you can pause the video and read the question. So determine, giving reasons, the size of angle O2. Okay, we have to determine the size of angle O2, this angle O2. So if you pay attention, you are going to see that the angle K1 is subtended by the arc PN or the chord PN. If you draw a chord, so the angle K1 is subtended by the arc PN or the chord PN, and the angle O2 is also subtended by the same arc or the same chord if you draw a chord. So the two angles are subtended by the same arc or the same chord if you draw a chord. Okay, so remember, when you have two angles, one at the circumference and another one at the center, subtended by the same arc or the same chord, the angle at the center is going to be twice the angle at the circumference. So the angle O2 is equal to 64 degrees. Okay, 32 times 2, you have 64 degrees. Okay, so angle O2 is equal to 64 degrees. Okay, 32 times 2, you have 64 degrees. Okay, so give the reason. The reason, you are going to say angle at the center is equal twice angle at the circumference. Now, question B. Determine the angle O1. Okay, determine the angle O1. This angle O1. So we can find the angle O1 using this line, the line KOM. Remember, the sum of the angles on a line is equal to 180 degrees. So we need angle O3 so that we can find angle O1. Okay, we need angle O3 so that we can find angle O1. Okay, so to find the angle O3, we can use this triangle. Okay, we can use this triangle. You know, the sum of the interior angles in a triangle is equal to 180 degrees. So we need this angle, the angle M2, so that we can find the angle O3, and then we are going to find the angle O1. So can you see, you have a line from the center. Okay, O is the center of the circle. Okay, you have a line from the center to the midpoint of a chord. Okay, you can see KOM bisect chord LN. So you understand, M is the midpoint. So when you have a line from the center to the midpoint. So this angle is equal to 90 degrees. Okay, so angle M2 is equal to 90 degrees. The reason you have a line from the center to the midpoint of the chord. Okay, so the angle is always equal to 90 degrees whenever you have a line from the center to the midpoint of the chord. That line is always perpendicular to the chord. Okay, so for that reason you have the angle M2 equal to 90 degrees. Now we can use this triangle to find the angle O3. Okay, so angle O3 is equal to 180 degrees minus 90 degrees minus 26 degrees. This is equal to 64 degrees. The reason you are going to say sum of angles in a triangle OMN. OMN. Now we can use the line KOM to find angle O1. Okay, so angle O1 is equal to 180 degrees minus angle O2, which is 64 degrees, minus angle O3, which is 64 degrees. So angle O1 is equal to 52 degrees. The reason you are going to say angles on a straight line. So we have the angle O1. Okay, we can find the angle O1 using another way. Okay, let's use another way. You can use the exterior angle of the triangle OMN. Okay, remember the exterior angle of the triangle OMN is equal to angle M2 plus 26 degrees. So we need the angle M2 so that we can find the exterior angle, and then we are going to find angle O1. Okay, so angle M2 is equal to 90 degrees. The reason you are going to say you have a line from the center to the midpoint of the chord. This is why angle M2 is equal to 90 degrees. Okay, now this exterior angle, the angle KON. Okay, KON, this angle. Let's find the exterior angle, which is KON, this angle. The angle is equal to angle M2, which is 90 degrees plus 26 degrees. This is equal to 116 degrees. The reason you are going to say exterior angle of triangle OMN. Now we need the angle O1. We have the angle O2 from the previous question. So we can find the angle O1 by subtracting the angle O2. So angle O1 is equal to 116 degrees minus angle O2, which is 64 degrees. This is equal to 52 degrees again. So let's move on. We're still on question 8.1. Now we are going to answer question 8.1.2. Okay, solution 8.1, 8.1.2. Okay, so prove giving reasons that Kn bisects angle OKP. Kn bisects angle OKP. Okay, this angle OKP, this angle. So if Kn bisects the angle OKP, this angle, you are going to have the angle K2 equal to 32 degrees as well. Okay, so using this triangle, you have to see, using the triangle OKP, you have to see that OK is equal to OP, because you have a line from the center to the circumference. Okay, from the center to the circumference. So this is a radius and this is another radius. So you have OK is equal to OP. So you have this angle is equal to this angle, because the two angles are opposite equal sides. Okay, this angle P, is opposite OK, and the angle OKP, this angle is opposite OP. So the two angles are opposite equal sides. Okay, OK is equal to OP. So angles that are opposite equal sides are also equal. So we can find the sum of the two angles, and then we are going to divide by 2 because the two angles are equal. So using this triangle OKP, you have angles in this triangle. So you have angle OKP, this angle, plus the angle P, plus the angle O1, this is equal to 180 degrees. Okay, the sum of the interior angles in a triangle. Okay, so the reason for this, you are going to say sum of angles in a triangle OKP. Okay, OKP. The sum of the interior angles in this triangle is equal to 180 degrees. So let's find the sum of the two angles that are equal. Okay, so angle OKP, this angle, plus the angle P, this is equal to 180 degrees minus angle O1, which is 52 degrees. Okay, from the previous question. So angle OKP plus angle P, this is equal to 128 degrees. Now we can divide by 2 because this angle is equal to this angle. We can divide by 2. Okay, so you have angle OKP is equal to the angle P. So this is equal to 64 degrees. When you divide 128 by 2, you are going to have 64 degrees. The reason you are going to say, because you have angles opposite equal sides. Okay, OK is equal to OP. So you understand angle K2 is 32 degrees because 32 plus 32 you have 64 degrees. So angle K2 is equal to 32 degrees. You can conclude, therefore, Kn bisects angle OKP, this angle. Okay, another way to answer this question, you can use this triangle. Can you see? OK is equal to ON. Now, this angle is equal to this angle because this angle is opposite the sides ON, and this angle is opposite OK. So OK is equal to ON. Okay, OK is a radius, ON is a radius as well. So OK is equal to ON. So angles that are opposite equal sides are also equal. Okay, so you understand angle K2 is equal to the angle KNO, this angle. Okay, KNO, this angle, because these are angles opposite equal sides. So we can find the sum of the two angles, and then we are going to divide by 2 so that we can find each angle, because the two angles are equal to each other. So remember, we have this angle from the previous question. This angle is equal to 116 degrees. So angle K2 plus angle KNO, okay, angle K2 plus angle KNO, this angle, this is equal to 180 minus this angle, which is the angle KON. Okay, so the reason you are going to say sum of angles in a triangle KON. So angle K2 plus angle KNO is equal to 180 minus 116. Okay, this angle is 116 degrees. This is equal to 64 degrees. So to find each angle, you are going to divide by 2 because the two angles are equal to each other. So angle K2 is equal to 32 degrees. When you divide by 2, you can see again angle K2 is 32 degrees. So therefore Kn bisects the angle OKP. Okay, Kn bisects the angle OKP. You can see. Okay, let's move on. Now question 8.2. In a triangle ABC, F and G are points on sides AB. You have F on sides AB, and on sides AC you have G. Okay, F and G are points on sides AB and AC respectively. D is a point on GC. GC, you have D on GC, such that the angle D1 is equal to the angle B. Okay, so question 8.2, we are going to answer question 8.2.1. So if AF is a tangent to the circle passing through points F, G, and D. Okay, F, G, and D. If you have AF is a tangent to the circle passing through these points, okay, then prove giving reasons that FG is parallel to BC. FG is parallel to BC. So remember lesson 4 of 25 on parallel lines. Okay, so for this line FG to be parallel to the line BC, this angle, let me show you, this angle must be equal to this angle. Okay, corresponding angles. Remember lesson 4 of 25, you are going to have the F shape, okay, F shape. Remember lesson 4 of 25, you can check that lesson. Okay, lesson 4 of 25. Okay, so let me erase. So you are told you have a circle passing through points F, G, and D. Okay, F, G, and D. You have this circle. Okay, so we can use this circle to prove that this angle F1 is equal to the angle B. We can use the circle. Okay, so using AF as a tangent, you have the angle F1, between the tangent and the chord FG. Okay, this angle F1 between the tangent AF. Okay, AF is a tangent, you have the angle F1 between the tangent and the chord FG. So this angle is equal to the angle D1 using tangent chord theorem. Okay, from the same chord you have the angle D1 from the same chord. Okay, so angle F1 is equal to the angle D1. The reason is tangent chord theorem. Okay, tangent chord theorem. You are also given angle D1 is equal to the angle B. You are given that. Okay, so angle D1 is equal to the angle B. Okay, angle D1 is equal to the angle B. You are given that. So this is the reason you are given that. Now, can you see angle F1 is equal to the angle D1, angle B is equal to the angle D1. Okay, so this angle B is equal to the angle D1, angle F1 is equal to the angle D1. Okay, D1. So automatically angle F1 is equal to the angle B. Now you can see the corresponding angles are equal. Okay, angle F1 is equal to the angle B. So automatically, therefore, FG is parallel to the line BC. The reason you have corresponding angles equal, okay? The corresponding angles are equal, okay? Angle F1 is equal to the angle B. Because of that, FG is parallel to BC, okay? Question 8.2.2. Now, if it is further given that AF over FB is equal to 2 over 5 and AC is equal to 2x minus 6 and GC is equal to x plus 9, then calculate the value of x, okay, for max. So we have proved FG is parallel to the line BC, and you have triangle ABC. Since you have a line parallel to one side of a triangle, you can use the triangle proportionality theorem, okay? Since you have a line parallel to one side of a triangle, you can use the triangle proportionality theorem, and from there you are going to solve for x, okay? So using the triangle proportionality theorem, you are going to say AF over FB is equal to AG over GC, okay? Because you have a line parallel to one side of a triangle, you can use the triangle proportionality theorem. So using this theorem, we are going to solve for x, okay? So AF over FB is equal to AG over GC. So the reason you are going to say you have a line parallel to one side of a triangle, okay? Line parallel to one side of a triangle. This is the reason. Or you can say the reason is proportionality theorem FG parallel to BC. So now we have AF over FB, okay? AF over FB is equal to 2 over 5. We don't have AG, okay? We don't have AG. We have GC. GC is equal to x plus 9. We have AC. AC. This is AC. AC is equal to 2x minus 6. So we need AG. We have GC and we have AC. So we can find AG taking AC minus GC. You are going to have AG. So AG is equal to AC, okay? AC minus GC, okay? AG is equal to AC minus GC, okay? So this is equal to AC is equal to 2x minus 6 minus GC in bracket, okay, x plus 9. Okay, because the minus is going to affect everything. Okay, GC in bracket, you have minus in front of GC. This is GC. Okay, so this is equal to 2x minus x. This is x minus 6 minus 9. This is minus 15. So AG is equal to x minus 15. Now you have everything. You are going to substitute into the equation and then you can solve for x. So AF over FB is 2 over 5. This is equal to AG. This is AG over GC. This is GC. Okay, now you are going to cross multiply and then solve for x. So cross multiplication, you have 2 times x, 2x plus 2 times 9 plus 18 equal to, now 5 times x, 5x, 5 times negative 15 minus 75. Now you have 18 plus 75. Okay, negative 75 to the left, 18 plus 75, you are going to have 93 equal to 5x minus 2x, you have 3x. So x is equal to 31 when you divide by 3 on both sides. Okay, so we have x. We can also use this combination. Let me show you. You can take AF over AB equal to AG over AC. Okay, you can use this combination to solve for x. So we can say, or you can solve this question using this combination. AF over AB is equal to AG over AC. Okay, AF is equal to 2, AB is equal to 7. Okay, FB is 5, AF is 2, so AB is 7. Okay, can you see? AF is 2, FB is 5, AB is 7. 2 plus 5, 7. So you have AF, which is 2, AB 7, AG, this is AG. Okay, AC is given. So the reason why you can write the proportionality equation, you are going to say you have a line parallel to one side of a triangle, or you can give the reason as proportionality theorem, FG parallel to BC. Okay, so AF is 2 over AB is 7 equal to AG. This is AG over AC. This is AC. Now you are going to cross multiply. So you have 4x minus 12 when you cross multiply. Okay, 4x minus 12 equal to 7x minus 105. Okay, 7x minus 105 when you cross multiply. So you are going to have negative 12 plus 105. Negative 105 to the left, you have positive 105 minus 12, you have 93 equal to 7x minus 4x, you have 3x. Again, x is equal to 31. Okay, so we have 31 again. We can solve this question using another combination. So using another combination, you can say FB over AB equal to GC over AC, because you have a line parallel to one side of a triangle. So you can use the triangle proportionality theorem. Okay, so you have FB over AB is equal to GC over AC. The reason you are going to say, because you have a line parallel to one side of a triangle, or you can say proportionality theorem FG parallel to BC, FG parallel to BC. Okay, so FB is equal to 5, AB is equal to 7. Okay, 5 plus 2, 7. And GC is given, AC is given. Okay, so FB is 5 over AB 7 equal to GC is given over AC is given. You are going to cross multiply. So you have 10x minus 30. Okay, 5 times this, 10x minus 30. Okay, equal to 7x plus 63. 7x plus 63. Now you have 10x minus 7x, which is 3x, equal to 63 plus 30, which is 93. So x is equal to 31 again. Okay, so we are done with question 8 from November 2020 from DBE. Okay.